Hey guys, welcome back. So it's been a little while since we've made a video, but our college actually started a month ago, and so things have settled down a little, and we're gonna try posting videos as much as we can and whenever you get the time. And so without further ado, uh, this is Leetcode problem number 13. This is gonna be converting Roman numerals to integers. And so I'll just read out the problem really quick. Roman numerals are represented by 7 different symbols: IV, XL, CDM. These are the values that they represent. 2 is represented by II, just two ones added together. 1, 2 is represented by XII, which is simply X plus II, which would be 10 plus I plus I is 2. So it's 10 plus 1 plus 1, which would be 12. 27 is represented by XX VII, or this, XX plus V plus II. Roman numerals are usually written from largest to smallest, left to right. The Roman for 4 is not just III, it's actually represented by IV. And so because the 1 is before the 5, we subtract it, making 4. The same principle can be applied to 9, which is written as IX. And you can do the same thing for 5, 10, or not for 5, 10, for 4, 9, 40, 90, 400, and 900. And so our goal is going to be to analyze the Roman numeral and return the correct output which it represents. And so it's a pretty self-explanatory question. I'm going to get started right away. And so I already created the Romans dictionary, which houses the values that are represented by the symbols. I'm going to declare a variable called Roman int and set that equal to 0. I'm also going to declare a variable idx, which is going to represent the index. And so what I'm going to do is I'm going to loop through the Roman numerals here. And every time I loop through and look at a Roman numeral, I'm going to first check the Roman numeral after, see if that value is higher than the one that I'm currently on. If it is, then I'm going to have to subtract, like we saw over here. I'm going to have to subtract. But if that's not the case, I'll just add it. And if I do end up subtracting, I'll increment my IDX by 2. If I don't, I'll just increase my IDX by 1. And so I'll go through a quick example. If we look at this one, our first are in IDX equals 0. We have M, which represents 1,000. And so we're going to add 1,000 to our Roman int. And then we're going to move over to our next Roman numeral, which is C. And if we look at this one, we have an M again. And so since the M is greater than the C and it comes after, we're going to have to subtract it. So we're going to do 1,000 minus 100, which is going to be 900. And then we're going to add that to our Roman int. And then we're going to increment our IDX by 2. So instead of going to M, we're going to jump over to the X. And so if we look at X, the C is greater than the X. And so we're going to subtract 100 minus 10, which is going to be 90, since that's what XC is going to represent. We're going to jump over twice to get to the IV, and that represents 4, and that's going to be the end of our Roman numeral. And so that's basically kind of a working example. And the way we're going to code that, I'm going to first create a while loop and say while IDX is less than the length of S. So we want to make sure the very last, if we have a string of length 2, the last Roman is going to be, the IDX of the last Roman is going to be the length of S minus 1, which in this case would be 1. In this case, since it's 1, 2, 3, 4, 5, the index of our last I would be 4, and so on. And so I'm just making sure that we're at the, we're before the end of we're before the length of S, which means we're still in the Roman numeral. And so if that's the case, what I'm going to check is if IDX is less than length of S minus 1. And so what that's checking to make sure is if there's still one Roman numeral after the current one that I'm on. Because if I'm on V, where the IDX is length of S minus 1, I don't have a Roman numeral to check after. But if I look at I do have a Roman numeral to look afterwards, and the IDX of this is going to be the length of S minus 2, which is going to be the length of S minus 1. And so this is just a check to make sure that I have a Roman numeral to check after. And so if that's the case, if our IDX is less than our length of S minus 1, and our Romans of that IDX plus 1 is greater than our Romans of our S of IDX, we want to subtract. And so when I'm going to say Roman int plus equals I'll actually copy this over to make it a little quicker. I'm just going to subtract. And then I'm increment my IDX by 2. And so what that does is we're checking to see if we can check for a Roman numeral afterwards. If our IDX is less than the length of s minus 1, we know that there's still a Roman numeral we can look at after. And what I'm going to do, I'm going to check if it's bigger than the one that we're currently on. So I'm checking the value of the one the IDX after with the one that I'm currently on. If it's bigger, I'm going to subtract them and add them to my Roman int and increment my IDX by 2, like we did over here. Cm represent 1,000, we moved our IDX over 2. Else, so there's kind of two situations in the else. One else is well, not necessarily two situations, but we know that if our IDX is not less than length of s minus 1, that means we're on the very last index, so we can just add that. But in another case, if we're looking at, say, for example, this m, we know that the Roman numeral after, which is c, is not, the value of c is not greater than m, so we can just add the value of m, and this should be completely fine. And so what I'm going to say, Roman int plus equals Romans of s of IDX. And then I'm going to increment my IDX by 1. And so that is going to handle for if the Roman numeral after is not greater than the one that we're currently on, or we're on the very last Roman numeral. And so if we're on the very last one, we're going to increment our IDX by 1. It's going to end the while loop, and then we're going to return the Roman int. And so let me just Roman int, and so that's the end. That should be the end of our Roman to int function. If I run the code, you saw the test case was I. If we run it, we get 3. And so I'll copy this one over. If we run this, we should get 1994. We get 1994. And so again, what's happening is we start off at the 0 index. We check to see if the index after is, the value of the index after is greater than the one we're currently on. If it isn't, which in this case m is value greater than c, if it isn't, we just add it. If it is, then we're going to subtract the value of m minus the value of c and add that to our Roman int. And we're going to increment our IDX by 2. And so we're just switching between these two. We're checking for those cases. And then at the very end, once we've looped through the entire string, we're going to return our Roman int. And so that is that. I'll actually run another test case here to make sure that the IV works, which it does. We get 4. And so I'm actually going to submit now, and it's going to run some test cases on the back. And so we see here we completed it, and we actually got good results. And so that's how we code up the Roman to int function on this Leetcode problem. Hopefully that helps, and see you guys in the next one. All right, later.